All right. Suppose the sequence an converges to A. Show that the sequence 1 over an converges to 1 over A. Is this always true? So obviously when an is 0, this is not true, and when A is 0, this is also not true. So we kind of have two conditions that have to be true. Two conditions that have to be true for this to be true. We cannot have either of these be 0. So we'll run with the proof assuming that they're not 0. We can include it in our proof, I suppose. Let A be not equal to an be not equal to 0. So they're both not equal to 0. Okay, and our assumption is that we supposed an converges to A, so we have that for every positive epsilon, there exists some natural number n, such that for all little n greater than or equal to capital N, we get this absolute value of an minus A is less than, all right. Because we want to talk about 1 over an, we'll do this kind of scratch work live. So the thing we want to have is 1 over an minus 1 over A, and we want to show that this is less than epsilon. So we're going to have to choose this carefully, and we have two fractions, and so we're going to get a common denominator and combine the fractions. So that will give me A minus an, whoops, over A times an, and absolute values in a fraction, we can just take the absolute value separately, and because it's absolute value, it doesn't matter the order, which is nice because the top is just this half. So we have the absolute value of an minus A over the absolute value. I'm also going to split these because the product of two things in an absolute value doesn't matter. There we go. And now we know that the condition we want to be absolute epsilon, and I see. We also know that since an converges, it's bounded by some m, so we have a bound for this guy, and, sorry, we have a bound for this side, and to get rid of this, we just choose the top bit to be epsilon over A, absolute value A. And we want to get rid of that one with an m2 over m. So the m is the bound on the sequence, so I want to introduce that earlier in the proof. For every epsilon greater than 0 and m greater than 0, we have this, and my prerequisite will be since the sequence an converges to A, it is bounded by m. So we get this inequality, which we know is less than epsilon, let's see. Yeah, I shouldn't have put this in the bottom because we want to cancel it out with that. So I'm going to rework that to be absolute value A times m. So the top half becomes absolute value A times absolute value this times m. And we're dividing by absolute value A. So these cancel out. And this m, because it's bounded, we can say that. And so this gives us nicely the inequality that we wanted. And so we have that the sequence 1 over an converges to 1 over A. And we know that it only holds under the condition that A and an are never 0. All right, that's the proof.